Hello everyone. We will now work through some of the questions under the free response section, starting with the first one. Now you have to remember that for these questions, it is absolutely important that you show all the steps of your work because every step will have points assigned to it. And if you just give the final answer on your assignment or on your test, then you will get only the points assigned for the final answer. Every step has points assigned to it, so please make sure that you show as many steps as possible before you get to the final answer. The first question is, use the given right triangle to answer the following questions. Show your work as appropriate. So this diagram here is that of a right triangle. We have been given the measures of side A, which is 5, and the hypotenuse, which is side C, is 10. We have to find B and then answer some of the related questions to this particular problem. The first part of the question says, find the length of the unknown side, which is side B of the figure. Now, this being a right triangle, if we know the measures of any two sides, we can use the Pythagorean formula to find the unknown side. Recall what the Pythagorean formula is. It's a squared plus b squared equals c squared, representing the sides of the right triangle. And side C is always the hypotenuse, and A and B are the two legs of the right triangle. So let's apply the formula here. Side A has a measure of 5 units. Side C has a measure of 10. The formula, write it out please. It's A squared plus B squared equals C squared. Plug in the value of A correctly. So it becomes 5 squared. So A squared is written as 5 squared. B squared is what we need to find. And C squared, C has a value of 10. So it's 10 squared. We have to solve for B. Start by solving for B squared first. Isolate B squared on one side. Move the 5 squared over to the other side. It becomes 10 squared minus 5 squared. 10 squared is 100. 5 squared is 25. 100 minus 25 is 75. However, we have to find the value of B, not just B squared. So in order to do that, we take the square root of both sides, correct? So if we have B squared equals 75, then B will be the square root of both sides. B will be square root of 75. Now we can simplify this further. 75 can be written as 25 times 3. In order to simplify it, find out if there is a way of extracting a squared value from the 75. 75 is rewritten as 25 times 3, where 25 is a squared number. So then you separate each of these values under separate square roots. Square root over 25 is 5, and square root over 3 has to stay as is. So the final answer is B is 5 times square root of 3. So A is 5, B is 5 times square root over 3, and C has a value of 10. So that completes the first part of the question, part A. Let's go on to what the next part is. It says, find the trigonometric ratios for the angle A. We don't know what the measure of the angle is, but since we know the value of the three sides of the right triangle, we can form the different ratios. So sine of angle A. Now let's go back to the figure because it's important to know which side is opposite and which side is adjacent to angle A, and the hypotenuse is always the same no matter what angle we are working with, right? So as far as sine of angle A is concerned, it's A over C. So here is our triangle. This is angle A. So its opposite side is side A, the adjacent side is B, and the hypotenuse is C. Right? So sine is opposite over hypotenuse, therefore A over C. A has a value of 5. We missed a step here, so let me just write that. A has a value of 5. So 5 upon 10, which is 1/2. Next is cos of angle A. Cosine is adjacent over hypotenuse. Adjacent side to angle A is B, so it's B over C. B has a measure 5 times square root over 3 and C has a value of 10. So 5 and 10 can be divided. So we have 1 in the numerator and 10 divided by 5 is 2. And that's how we end up with square root over 3 by 2. The next one is tan of angle A. Tangent has the ratio opposite over adjacent. A is the opposite side to angle A and B is the adjacent side to angle A. So it's A divided by B. 5 is the value of A. So 5 divided by 5 times square root over 3. 5 and 5 will divide. So we'll be left with 1 divided by square root over 3. We will multiply both the denominator and the numerator by square root over 3 to rationalize the denominator. We do not want radical signs in the denominator of a fraction. So that is why we need to rationalize it, and we do that by multiplying the denominator by square root over 3. Because we have a square root over 3 in the denominator, if we multiply it by another square root over 3, it'll become a 3 without the radical sign. However, 1 times square root over 3 in the numerator is square root over 3 divided by 3 is the tangent of angle A. Cosecant of angle A, we can apply the reciprocal identity, but we know that cosecant is C over A. It's the reciprocal of sine. So if you flip the numerator and denominator of the sine function, you will get the ratio for the cosecant function. So it's C divided by A. C was 10, correct? So I should write 10 divided by 5. 10 can be divided by 5 for 2 over 1. This is 10 divided by 5 is 2. 5 divided by 5 is a 1. So 2 divided by 1 is equal to a 2. So cosecant of angle A has a ratio of 2. Secant is the reciprocal of the cosine function. So we can flip the numerator and denominator of the cosine function. Secant would be C over B. Cosine was B over C. Secant would be C over B. Plug in the value for C in the numerator, which was 10. B has a value 5 times square root over 3. Again, 10 divided by 5 is 2. So we have 2 divided by square root over 3. However, we need to rationalize the denominator. So multiply both the denominator and the numerator by square root over 3. Square root over 3 times square root over 3 in the denominator is a 3. 2 times square root over 3 is what we have in the numerator. So the final answer is 2 times square root over 3 by 3. As far as cot of angle A is concerned, it's the reciprocal of the tangent function. Therefore, if we flip the numerator and denominator of the tangent function, we will get the ratio for cotangent. Tangent was A over B. Cotangent would be B over A. Plug in the value for B, 5 times square root over 3. A has a value of 5. So let's divide 5 and 5. We are left with square root over 3 for cotangent. The next part says find additional trigonometric ratios for the given angles, but this time it's all angle B. So let's draw the triangle here to identify where angle B is. So here we have the right triangle. This time we are working with angle B and we are finding all the ratios related to angle B. The opposite side to angle B is the side B and the adjacent side this time is A. So sine of angle B would be opposite over hypotenuse, which is B over C. So B has a value 5 times square root over 3. C has value 10. Simplify this. 5 and 10 both can be divided by 5. So we can make this square root over 3 by 2. And that's the answer for sine of angle B. Cosine of angle B would be adjacent over hypotenuse. Adjacent side to angle B is A. So A divided by C. A has a value of 5. C has a value of 10. When we simplify this, it can be reduced to 1/2. And that's the answer for cosine of angle B. Tan of angle B is B over A, opposite over adjacent. Opposite side is B, adjacent side is A. So 5 times square root over 3 in the numerator for B, and A has a value of 5. Again, you can simplify this and write it as square root over 3, which is the ratio for tan of angle B. Cosecant of angle B again is the reciprocal of the sine function. So just flip the numerator and the denominator of the sine function to get the value of the cosecant. So C divided by B is 10 divided by 5 times square root over 3. Again, we can divide 10 and 5 and we'll get 2 divided by square root over 3. However, we need to rationalize the denominator, therefore multiply both the numerator and the denominator by square root over 3, and the answer is 2 times square root over 3 in the numerator divided by square root over 3 times square root over 3 gives us a 3, right? Square root squared is a value without the square root, correct? Square root over 3 squared is 3. And so that's how we ended up with the 3. Secant of angle B. Secant is the reciprocal of the cosine function. So just flip the numerator and denominator of the cosine function. We'll end up with C divided by A. C has a value 10. A has a value 5. 10 divided by 5 is 2, and that is what the secant ratio is for whatever value angle B is. Cot of angle B, reciprocal of tan. So what was B over A for tan will become A over B for cotangent. So plug in the values. A has a value 5. B has a value 5 times square root over 3, and then 5 and 5 divide. So we have 1 divided by square root over 3. Again, we need to rationalize because we have a radical in the denominator, and we end up with an answer which is square root over 3 divided by 3. All right? The next part of the question says, based on your knowledge of special angles, what is the value of angle A and angle B? Now, you can just go over the angles and you should know the ratios of the special angles. So the way we'll work this out is, what is the angle whose sine ratio is 1/2? It's the 30-degree angle, correct? In other words, we are trying to find the angle whose sine ratio is 1/2. It's 30 degrees from our knowledge of special angles. So that's what angle A is. To find angle B, you can just subtract the 30-degree value for angle A from 90 degrees and know that it's 60 degrees. Again, because this is a right triangle, angle A and angle B are complementary angles. Therefore, angle B will be 60 degrees. However, you can also just look at all the ratios for angle B. Pick any one ratio. We know that the angle whose cosine is 1/2 will be a 60-degree angle, again based on our knowledge of special angles. All right, so that's another way you can figure out what angle B would be. But if you know angle A, you can just subtract that value from 90 degrees to get the other acute angle. Now, the last part of this question says, find the value of cos of pi over 3 times secant pi over 3 minus cot of pi over 3. Now, if you can remember that a 60-degree angle and pi over 3 is the same angle measure, degrees to radians, then you can just look up the ratios from this table, because now we know that angle B is a 60-degree angle. So if you know that pi over 3 is equal to a 60-degree angle, then go back to your work. Cos of 60-degree angle, so cos of angle B is 1/2. So that's how I got the 1/2 here. Secant of 60 degrees or secant of pi over 3 is 2. Let's go back over here. Secant is 2. That's how I came up with the 2. Minus cot of pi over 3. Pi over 3 is again 60 degrees, a cot of the 60-degree angle B is square root over 3 by 3, and then you just complete the calculation. Half times 2 is 1, so 1 minus square root over 3. We have to leave the answer in this form. You do not need to use your calculator to write it as a single numerical value. It's good enough if you leave it like this. In fact, this is how I would want it to be shown as the final answer. All right? Let's work on question number 2 now, which says a circle has a radius of 15 inches. Find the length of the arc intercepted by a central angle of 150 degrees. Now, this is a question on radian measure. We've been given the radius of a circle, which is 15 inches. We've been given the measure of the central angle. We've been asked to find the length of the arc. Now, before I go into solving it, let me just draw the circle here. Let's just draw this circle and try to picturize it. The radius of the circle, R, so this is the radius, has a value of 15 inches. Correct? That's the radius of the circle. The central angle is this angle here. We'll call that theta, and theta has a measure given to us as 150 degrees. The intercepted arc is the portion of the circle that is intercepted by the central angle. So this length is what we need to find, and that is denoted by the letter S. We know the formula for the radian measure is theta equals S divided by R. Therefore, S can be found by multiplying theta by R. Correct? You just have to solve for S in this equation. That's all there is to it. However, the angle measure given to us is in degrees. We first have to convert that to radians in order to be able to use this formula. So the first step would be to convert 150 degrees to radians. How do we do that? You take your angle measure in degrees and multiply it by the conversion ratio, which is pi over 180. And then we simplify that. 150 and 180 can be simplified further, and we get a value of 5 pi over 6, which is the radian equivalent of 150 degrees. Once we have the angle measure in radians, we can go over and use this formula. Substitute 5 pi over 6 for theta. S is what we have to find, so that remains as S. But R, the radius, is given to us as 15. Plug in 15 for R, and now we have to solve for S. We have to isolate S, so multiply both sides by 15. 15 and 15 will divide on the right-hand side. So we will have S equals 15 times 5 pi over 6 that I've done here. 15 times 5 is 75 pi. That's what we have in the numerator. In the denominator, we have a 6. Now 75 and 6 have a common factor. The greatest common factor of both these values is 3. So we can reduce this further and write it as 25 pi over 2. And that is what the answer is. S equals 25 pi over 2. That's the final answer. Again, you have to remember to show all your steps to get full points for this question or for any question under the free form section. All right?